Our last differential equation that we are going to consider is a second order non-homogeneous equation that has imaginary homogeneous roots with duplicates. So our first step with this equation is to solve the homogeneous. And we did that in the last video. If you didn't get a chance to look at that, look at it now. And our solution for the homogeneous turned out to be C1 cosine 2t plus C2 sine 2t. Now, since we have a sine function on the right-hand side of this equation, and if we follow the same pattern that we followed before, we thought, well, we would need a non-homogeneous test solution to throw into our differential equation. Would be a cosine 2t plus b sine 2t. And that's just our homogeneous solution. So that can't be it. Well, we got away with getting around this by multiplying by t, by our independent variable. Forgot my constant a. Actually, I need to put the t out by itself, and then I can carry the constants inside. And if you notice, this is going to get very messy very quickly because I have to use the product rule, and I have a second order, which means I'm going to probably use the product rule at least 3 times, possibly 4 times. And so this gets really, really, really messy. So let's look at it if we were to use Euler's. So if I were to use Euler's, we're going to completely change the equation. It's going to be a brand new problem. And on the right hand side, I'm going to change this to my Euler relationship, I'm sorry, 3 times e to the 2jt. Now I can come up with my test solution in imaginary form, and I still have to multiply by t to make it independent, and that gives me a t e to the 2jt. And when I go through this process and I go to get back to my original, because I'm looking at the sine function on the right hand side, I want to take the imaginary part. If it was a cosine, I'd be taking the real part, but in this case I'm going to take the imaginary part for my solution. Well, let's do the double derivative of a t e to the 2jt. And I think you'll find this to be much easier. We're still going to have to use the product rule. But it will be much simpler. The a will just come out, and then I'm going to have t, derivative with respect to t, e to the 2jt, plus e to the 2jt, derivative of t with respect to t. So I have t, derivative of e to the 2jt is 2j e to the 2jt, derivative of t with respect to t is just 1, and now we can do a little simplifying. Now do the derivative again. The a just comes out. And now we just need to simplify. Notice we can do the derivatives here. And the derivative of 2jt plus 1, well, remember j is just a constant, so it's going to be 2j. And our derivative of e to the 2jt is just 2j times e to the 2jt. And now I can bring out my e to the 2jt, and I just have to simplify inside the brackets. So 2j times 2j is going to be 4j squared, so that's minus 4t plus 2j, and this will simplify. We have 2j plus 2j, so it's going to be ae to the 2jt minus 4t plus 4j, and that's minus 4a e to the 2jt, and we're going to have t minus j. So now we can put this back into our differential equation. Oh, actually, we've already done this. So I have minus 4a e to the 2jt t minus j plus a t e to the 2jt is equal to 3e to the 2jt. Notice that our e to the 2jt's cancel out. We're going to have 4t, I'm sorry, 4at. Oh, and I forgot my 4 there. Sorry. I forgot the 4 here. So minus 4a t plus 4j a plus 4a t equals 3. And now the minus 4at and the plus 4at cancel, and I'm left with 4j a equals 3, or a equals 3 over 4j. And if I multiply both top and bottom by j, then the bottom is going to give me j squared times 4, which is going to be minus 4, and our simplified is negative 3j over 4. Now I can put this back into our solution. I can use Euler's. This is a t, remember. I'm going to put the t in the front here. And distribute through our constant a. simplify. J squared is -1 times this negative gives me plus 3/4 sine 2t. And now, remember from our previous discussion, because we were looking at the sine, we want to solve our original equation. Since we were looking at the sine, we want the imaginary part of this solution for the Euler form to be able to come up with our solution. So our solution is going to be the homogeneous part plus the non-homogeneous part, and remember we're just going to take the imaginary of this, and this is C1 cosine two t plus C2 sine 2t minus 3/4 t, don't forget the t, cosine of 2t. Now I bet you never expected that when you had the sine on the right side of the equation that the solution would have the cosine for this part. Interesting how these equations solve. So make sure that you be very careful not to make assumptions about the solutions.